greatest common factor. The greatest common factor could be a number. It could be a variable. It could be both. All right. So could you tell me what number goes into both 5 and 15?
5.
Yes. That's the first thing, is there's definitely a 5 that goes into both. Now between x squared and x to the power of 1, you choose the smaller exponent. So that's x. So they call this the like divide and slide method. You're sliding out the 5x. What are you the result when you divide? So you got to kind of do it like one by one. Like what's 5 divided by 5? What's x squared divided by x? Can you tell me that here?
So it would be x plus 2x.
So it's x plus, and then 15 divided by 5 is 3.
Oh,
When the x's are on the top and the bottom, they cancel out.
okay. So that would be
All
that.
right. That's the final answer. Yeah.
Okay.
All right. So let me do a better job at stepping these. So for number 2, kind of the same idea. Look at number first. What's the biggest number that goes into both?
Um, 3.
3. So there's definitely a 3 that goes into both. Now you look at the x big. What's the smallest exponent between those two?
X squared.
Yeah, they're the same. So you just take x squared. Then you look at ways. What's the smallest exponent?
Um, X to the 4th. I mean, Y
Y
to
to
the
the 4th.
4th. Sorry.
Yeah. So you're essentially dividing each of these by 3x squared y to the 4th. Now this one's more complicated, but if I come up with the right here and look at the first one, like 3x squared y to the 5th, x squared y to the 4th. These cancel, these cancel. Y here, I've just the y there. You see that?
Mhm.
Okay. So you do the same thing for the other one. It's okay to kind of build this table. 6x squared y to the 4th, 3x squared. That makes 2. So this becomes y plus 2. Now, do you want me to give you any problems like these?
Yes, please.
Okay. So would have been better for me to give you one more like the first one. So let me go back and give you one like that. Let's do 8x squared plus 40. Look at the numbers first. Is there a number that goes into both?
5.
It's got to go into both
Oh,
8 and 40.
4.
Okay, is that the big number? That's the more challenging one. Is that the biggest number? So you should always try the smaller number. Like maybe the smaller number goes into both. Does
So,
8 go into both 8 and 40?
mm, yes.
And it does. And if you're allowed to just calculate, please have one out, or for our sessions, of course, maybe it's a good thing. So yeah, 8 goes into both. Now between x squared and x, which is the smaller exponent?
That's the X.
Just the x. So you're going to divide each of them by x. So 8x goes on the outside. What goes on the inside?
Will be x plus 5.
Okay, very good. Do you want another one like this or slightly different? What would you like?
One more like that.
Okay. So let's go 9x plus 15x squared. So this one's just a tiny bit different. Same process though. You look at the two numbers, 9 and the 15, and decide, what is common between them. What goes into both?
Um, wouldn't it be 3?
Yes, 3 goes into both. What about between x and x squared, which is the square?
Um, x by itself.
Yep. So 3x goes on the outside. What goes on the inside now?
X plus 5.
So you're dividing. What's 9 divided by 3?
Oh, um,
You're not subtracting. Right.
3.
3. The x's cancel. On the right, yeah, there's a 5, but what about the variables?
It will be
You got
5x.
x squared and x. Yeah, 5x. Good. Okay. You have to always tell me, hey, I want another one like that, or no, I think I got it.
Okay. I think I got it.
Okay. So let's do a couple more like 2. 2 is the more difficult. So let's say it's 4x squared y cubed plus 6x squared y squared. All right, so it's the same process. Look at the numbers first. What's what's common between them? What goes into both?
2.
2. Okay. So you're gonna divide both of them by 2. Now look at the variables. Look at the x. Which is the smaller exponent?
Um, the one with the 6.
Exponent here.
Mm,
You got x squared and x squared, which is the smaller exponent.
X squared.
Yep. So you can divide x squared is the common. Now how about y cubed and y squared, which is the smaller exponent?
Y squared.
All right. So let me just this you're gonna factor out a 2x squared y squared. Tell me what goes in parentheses now. Kind of look at each of them and decide what cancels or not doesn't cancel.
So 4x squared would cancel.
So it's piece by piece, right? Like what is 4 divided by 2? You could do that. Then x squared divided by x squared, then y cubed divided by y squared.
Okay, so it would be 2x.
The x squareds cancel are the same on the top and the bottom.
So it would just be 2.
Okay. Now you got, but it's y cubed, essentially 3 y's and 2 y's. How many y's are left over?
Mm,
So somewhere they should have teacher should have said like this, you subtract the exponents. It's 3 minus 2, which is y to the 1. Is that familiar? Have you seen that?
Yeah.
Okay. I mean, there's a number of ways to do it. The other way to look at it is y times y times y, y times y, and you can see that they cancel, leaving just the y. You have to decide how you want to do it. Plenty of options. All right, how about this? 6x squared y squared over 2x squared y squared.
So it'd be 3x, 3x.
Okay, but it's same degree exponent. So
Oh,
if you 2x to the 2 minus 2 is x to the 0, which
it'd just be 3.
yes. So give me some feedback here because I'm not sure. I definitely need to do another one, but I'm just wondering if you have like thoughts on this or that some concerns, something I can address specifically.
I just get a little confused about the exponents. Like,
The same if it's completely the same, like x squared over x squared, that just cancels, or if it was y cubed over y cubed, then it cancels. All right, let's try another one here. Let's try 5x cubed y squared plus 10x squared y cubed. What goes into both? Tell me, see if you can figure that out, please.
it would be 5x into both.
Okay, x to what power?
Mm, 1
What's the smallest exponent between x cubed and x squared?
x squared.
Okay, that's how you decide. We've done a couple problems like that. It's your responsibility to remember that. Now, what about y? What's the what should we write for y?
Y squared.
Yes. Okay, so tell me what this becomes when you reduce. Just go slow, piece by piece.
Would be it would be 1x plus
Good. Plus.
um, 2 2x.
So why did you say 1x here? Why didn't you include the y's on the left?
Oh,
This one's correct. I'm just asking you what your thought process was, because the same thing applies here.
I forgot about the y.
Your answer was correct, though. I'm not saying you did anything wrong. I'm, and you, it's three separate problems on each side. Like on the left here, it's 5 divided by 5. That's why you said 1. X cubed over x squared. That's why you said x. Y squared over y squared. What happens to those?
Would it just be y?
If they're the same on the top and bottom, that's why they cancel.
Mm.
So is the y squared the same on the top and the bottom?
Yes.
So it cancels. That's why it's x. You got to make an effort here to try these on your own. Like we've got a bunch of examples, the same thing over and over again. You expect what goes here?
Then it would just be y.
2y. Very. All right. I would recommend practicing those. So I don't know that we could spend more time on this, but I'm happy to give you more problems if you want. Or do you want to move on to factor by grouping?
After by grouping.
Okay. Let's take a look here. So all right. So factor by grouping is kind of related. Um, what is the GCF in those first two?
Sorry, what? You're cutting in and out.
What is the GCF of the first two? Like what is the number that goes into both? Just like we've been doing.
2.
It is two. And I do apologize. I do see the internet kind of is a little bit less stable than it normally is. Yeah, so 2 goes into both. How about between the x squared and the x?
Just, just the x.
Okay, so you're going to divide each of these by 2x. So what does that become?
Would be 6x. 6x. Oh, wait.
Minus.
Minus 5x.
It is not 5x.
Negative 5x.
Nope. If it's the same in the top and the bottom,
Oh, it
what did we
cancels.
do? Yes.
So it would just be negative 5.
Yes. Okay, now the next thing is really important here is you immediately put 6x minus 5 in parentheses off to the side here. I do apologize. I really don't understand what's happening. This issue was resolved, but maybe it's back. You have to figure out what goes here so that when you multiply in, you get back to the previous line. So what do you multiply 6x by to get 18x? Or what do you multiply 6 by to get 18?
3.
3. Really factor again. 6x minus 5 and then you bring the 2x plus 3 down like that. Any questions on that?
No.
Let's do another one. Like more like that one. Yeah, it's just all right. All right, so here's another problem for us to look at. Let's look at the first two terms. What's the biggest number that goes into 12 and 4?
2
It's got to go into both. A bigger number.
here. 4.
4. Yeah, 4 is the better number there. And then what about between n squared and n cubed, which is the smaller one?
N.
Smaller exponent.
Oh, N squared.
N squared. So you have to divide both of these by 4n squared. Can you tell me what goes?
Would be 3N plus
It's the same on the top and the bottom.
the exponents would cancel out since they're the same.
Just like in the previous problem, right? You had squared or x over x. What did that become? 1 y squared over y squared. What did that become?
It would just be N.
I mean, look, you got to look back to previous problems. Like they're not any different. It's x divided by x. And then did you write an x here?
Yes.
There's no x here.
Oh, sorry. No, I didn't.
So if it's the same, if it's exactly the same, it just cancels. It goes away. That's what I don't think you're fully, accepting, dealing with. Um, so what is 4 divided? Maybe you didn't hear me. What is 4 divided by 4?
1,
It is 1. So what is x divided by x?
X,
It's the same though. It's the same on the top and the bottom.
1,
If it's 1. What is n squared divided by n squared?
1,
It's 1. It's the same on the top and bottom. If it's the same, it's 1. What is 4n squared over 4n squared?
1.
1. Okay. And now the next part's a little bit confusing, but you put the 3n plus 1, whatever's in parentheses here, you immediately put it over here. Okay. And you figure out what goes as placeholder such that when you multiply in, you get back to the previous line. So what do you multiply 3n by to get 3n? How do you get back to yourself?
Wouldn't you just times it 3 times 1?
Yes. So then you factor the 3n plus 1 out, and you bring the other stuff down like that. Try that. I mean, Um, I think we should do one more. Why is my internet so unstable? This is unbelievable. Okay, here is another one. Okay, look at the first two terms here. What goes into both? Is there a number?
Wouldn't it just be 1?
Okay, there's the one that goes into both. How about between the variables? Which is the smaller exponent?
The x squared.
X squared. So you're gonna divide both by x squared. So what goes in parentheses?
Wouldn't it just be x
Okay, minus.
-4?
Very good. Then you immediately write that here. You got to figure out what goes in parentheses.
Wouldn't it be the +1? Oh wait, not the +1.
Yeah,
Uh,
sometimes it's better easier to look at the number. Like, how do you go from -4 to +20?
so it'll be
What would you multiply by?
5.
5 gets you to -20. We want to get to +20.
So -5.
Yes. And then you write x minus 4, x squared minus 5. All right, I got to get you to do one on your own here. Let me snip one in here for you to fully try. I'll leave this one up. Go ahead and try this one, please.
I got x minus 6, parentheses, x squared minus 4.
Very good. All right. Okay, let's look at your next problem here. We'll just work it out together and then we'll move on to 5 and 6, next grouping of problems here. All right, so we got between the first two terms here, you have a 4a squared that goes into both. Okay. So that becomes 5a plus 2b. So take a look at that, see if you have any questions on how I went from 20a cubed 4a squared to 5a. Obviously 20 divided by 4 is 5. A cubed divided by a squared is just the a. 8a squared b over 4a squared becomes 2b. Is that okay?
Yeah.
All right, and then you immediately write this over here. So we're trying to get back to either minus 15ab squared or minus 6b cubed. That's probably the easier one. Minus 3b squared. You can see if you distribute in minus 3 times 5 is minus 15. ab squared minus 3b squared times 2 is minus 6b cubed. So this becomes 5a plus 2b 4a squared minus 3b squared. To get that one down, maybe another lesson we can really work on that if you want to. I don't think you're even that extreme
Okay.
on your test, but something to think about.
Mm.
Is actually the easiest. Can you tell me two numbers that multiply to 15?
Um,
Two numbers that multiply to 15.
3 and 5.
Okay. I'm gonna write the other ones. Do these add up to, do any of these add up to 8? Does 1 plus 15 or 3 plus 5 add up to 8?
So 3 and 5.
So this becomes s plus 3, s plus 5. So the challenge is really all the numbers that multiply to the last. That's the challenge. Okay, so let's look at number 5. Negative 108. And remind me, are you allowed to use a calculator?
Yeah, I am.
Okay. So this is where a calculator really could help. Like we know that 1 times 108, that work. 2 and 54 work. Can you take 108 and divide it by 3?
36.
4 to 4 work. I haven't heard anything. Maybe you said 27.
7, yeah.
Does 6 work?
18.
15. Does 8 work?
No.
It does not work. Does 9 work?
12.
12, good. Uh, so eventually you run out of numbers, like you get to 10, 11, you get back to 12. Now, we really want negative 108. So it's really like this. It's really negative 1 and 108 or 1 and negative 108. If this one's negative, or it's 2 and negative 54, 3 and negative 36, 4 and negative 27, 6 and negative 18, 9. We want one pair to add up to positive 3. Do any of these add up to positive 3?
Um, the 9 and 12. So
Which one?
the negative 9 and the 12.
Yeah, so this becomes x minus 9, x plus 12. So what do you give me some feedback? What is difficult about this?
It's not so much these problems, it's the other ones with like the exponents and the cubed and squared.
Okay. Well, let me, always, I like hearing the confidence. This isn't to discourage you, but yeah, why don't you try doing number 6 then? And then we'll kind of gauge, okay, you know, do you have it or not? Um, that one, of course. Oh, this one, it does work. Thank goodness. Okay. Go ahead and give this a try, please.
I got x minus 7 in parentheses and then 7 plus 11.
I mean, x plus 11.
Yeah.
They've got to both have x in them. Very good. I would agree. You definitely know how to do that problem. So excellent job on that. All right. Number is related. So they don't say it, but you should always, always, always look for a GCF first. So that's what we're doing in the first like 4 or 5 problems, finding a GCF. So is there a number that divides each of these that goes into each of those?
5.
So we're going to divide each of these by 5. So tell me what goes in parentheses here, please.
Would it be x minus minus x minus 6?
Okay. Close. There's a small issue here. Um, Notice that like you can't combine any terms because they all have different powers of x.
Yeah.
Your issue here is related. There's something missing. Right? This should be an x squared because this was an x squared. Like the 5 doesn't affect that. Okay. Can you try factoring this now? You're looking for two numbers that multiply to -6, but they have to add to -1. You have an answer for me on that?
Just trying to figure it out.
Say that one more time.
I'm still trying to figure it out.
I'll help here. It's -1 and 6, or 1 and -6, -2 and 3, 2 and -3. Whenever you have a negative number, one has to be positive, one has to be negative. That's the only way. These add to -1. You're just looking for the one that adds to -1. Do any of these add to -1?
It would be -3 plus 2.
That's right. So it becomes x plus 2, x minus 3, like that. All right, let's go ahead and stop here for tonight. I do apologize again for the internet. I don't